Hello, I am Brock Stanton. I am an aspiring meteorologist, and today we are going to be talking about this enhanced risk, which includes the chance of tornadoes, possibly a few strong tornadoes, as well as very large to perhaps even giant hail. So that's 2 to 3 inches or even higher inch hail in diameter. However, despite the chance for very significant severe weather, the threat is a little more conditional upon storms firing along the dry line and maturing. The environment east of the dry line is very favorable for severe weather if storms fire, though due to a capping inversion, we're not really sure how many storms will fire, though I do think we're going to see at least 1 or 2 storms fire. I do think that at least. And then we are going to briefly talk about this day 3 risk, slight risk for severe weather here across southeastern Missouri up through approaching Chicago area. We'll be much more brief talking about that because it currently does not appear to be as significant of a risk, and like on every Thursday I have to go and be in at work at 6 o'clock Eastern time, and I'm recording this at 4:08, so I have to get everything done in this uploaded by about 5, so I just don't have too much time. But we're going to be taking a look at our HRW WRF ARW model first. I don't show this model as much. The reason I am showing this one and the NSSL first is because I think it's handling the moisture and temperatures for the system a little bit better, and as such I think it's handling the capping inversion a little better than what the NAM and HRR, which normally my 2 go-to model is showing, and I will still show those, but as we get into the day on Friday, we're going to see this model still has pretty strong moisture return, not quite as strong as the NAM, but I will say the HRR shows a lot less moisture return. It's kind of basically on its own with that, and that's why I'm not trusting the HRR as much. It's the only model showing not as much moisture, like maybe low 60s dew points for the most part compared to mid 60s dew points. That will make a difference with breaking the cap. And then the reason I don't like the NAM as much for this is because the system it's underdoing the temperatures, and at the surface, that's what I think it's doing, and that's because it's so much cooler at the surface, that means it's not breaking the cap. So, again, that's why I'm showing this model first, is I just think these 3 models probably have the best handle on the system, in my opinion. Of course, only time will tell if that is right, but we can see how our robust moisture access does develop here, and in that should help try and initiate storms. Let's just see as we move this through 0Z, see storms try and fire there. We are also going to just take a look at our surface temperatures just so we can compare these to what the other models are showing. We can see that, these generally 80s across central and eastern Oklahoma. These temperatures, these warmer temperatures here, there will probably be a fire risk on the backside of this dry line because you're going to have these very warm temperatures and very low humidity, so that should lead to an elevated fire risk. I'm not sure how elevated I'm not too good with forecasting fire risk, but there will be some sort of fire risk in this area. I'm pretty confident in that. So that's our temperature outlook. We'll see how it's much warmer than the NAM here in a little bit. But let's take a look at our CAPE now, and let's kind of see how this axis of CAPE does develop here into, let's see, by 22, let's go 23Z, because that's what it looks like when its advanced instability has not when the instability has advanced the farthest east, but when the dry line has made its farthest east advance. I'll just take a sounding here. This is in Oklahoma. You can see temperature dew point spread is about 19, which is marginal, but it is marginally supportive of tornadoes. You can see there's that turning photograph. There's no convective inhibition in this sounding, so it would take very little to get a thunderstorm to develop. And then here, let's just look areas further north. Let's just see, we know this model firestorms here. You can see that blob in the Cape. But you can see here, a little bit of turning in the photograph. Looks like probably the best level winds take a little bit to ramp up. But again, you can see very weak cap in place and moderate instability. So then we're going to take a look at our capping inversion, click on like a broad scale to see how this model likes to handle. It should be pretty weak overall. Yeah, we can see it's much weaker axis overall. Just dry lines about here. Look at this environment here with a pretty weakly capped environment. So that does suggest to me that would not take much forcing for storms to fire along the shoreline. Again, just time will tell on exactly how many, but this week, basically every model, I think except the NAM, is showing a pretty weak cap in place. So that does make me think storms will initiate. There's our capping inversion. We looked at our CAPE. Now we're going to take a look at our storm relative helicity values. And I will say, on the 0 to 1 level, they're not as favorable during the afternoon hours. It takes a little bit later here. Maybe perhaps in eastern Kansas they're more favorable, but it really takes, I don't know why the model's doing this weird image, but it takes to about, on this model, to about 0Z. I guess on with our models, say for like the more southern mode in Oklahoma, maybe around 23Z. So that's like, 6, 7 o'clock generally at or after dinner time for the strongest storm relative helicity values in the 0 to 1 kilometer to ramp up to really increase that significant tornado threat. But even, why is this model doing this annoying? But by 23Z, 6 o'clock, our 0 to 3 values are going to be more favorable, which does suggest that potential for tornadoes, perhaps a strong tornado as well. And now we're just going to take a look at our reflectivity output, see how this model does like to handle storm coverage. You can see here it fires the storms as a line of storms up here. And I think all models do fire this line of storms. And then, this is cluster of storms here, perhaps a supercell or two, and that's really all the storm does for this southern mode. I do think a little more coverage than that is possible, though. Again, I will say something else. All models warn this overnight line of storms, so I think that will contain a risk for damaging winds and hail, but I don't think it's going to be too significant of a risk. I think the main risk is going to be with these evening supercells that form. We are going to quickly take a look at our surface-based CAPE and photograph overlap for this model, and we're going to see how by 21Z they're curving a little bit, but not too much. That's 4 o'clock Central Time, 5, and into 6 o'clock we can see they start to curve a little bit more, especially further north. And then by 0Z, they're really starting to curve now across all of Oklahoma, and that's what does. So I do think it'll be in the evening hours when our strong tornado threat will increase. Here, just took a sounding. It says marginal tornado threat. I think overall the setup environment looks pretty good. Again, maybe that capping inversion isn't breaking. That could be what it is. But overall, I think our environment is going to be favorable for tornadoes. Again, perhaps some strong tornadoes. Very, very large hail. That's going to be a very significant risk. We're now also going to take a look at another model, our WRF and SSL. And again, we're just going to take a look at the moisture first quickly. And we're going to see how this model shows a much more robust moisture return. And you can see right where the dew points fall out, that's where storms initiate. So you can see we have 2 storms right here. Notice I'm not showing it on the reflectivity yet, I will later, but we can see how these storms fire in this very robust moisture return, probably, I believe, moderate, if not to strong instability, if I recall correctly. Would make sense based off of this. And I'll just take a sounding here across areas close to Oklahoma City. And by then, overall looks favorable for severe weather and perhaps a couple tornadoes, but I think by 0Z, 23-0Z, just check ahead a little bit northeast of that storm that's ongoing, you can see there's more curving in that photograph, which would suggest that increased risk for a tornado threat, perhaps a strong tornado as well. We can see that strong moisture return. Dry line appears to be a little farther west as well. We're also going to take a look at our temperatures. We're going to see how, again, by peak heating, anywhere from like upper 70s to mid 80s across most of the risk area in Oklahoma, and similar farther north, though it does look like maybe a bit cooler in areas further north, maybe due to some morning showers, but overall pretty warm, and that should act to limit the capping inversion a little bit. We're just going to take a look at it. To load in. Okay, there we go. And we can see it overall does weaken out a decent bit. Here, just take a sounding in this area. You can see how the caps, it's a pretty breakable capping now. how much a cap breaks depends on a combination of how strong the cap itself is and how strong the forcing is. So just because there's a weak cap in place doesn't guarantee thunderstorm development, but it does make it more likely than when a stronger capping inversion is in place. And let's just take another one further south. Again, got a weak cap in place, and areas further north we're still going to see generally a pretty weak cap in this quarter. So that does suggest thunderstorm development would be likely, capable of large hail, very large hail, and some tornadoes as well. We're going to take a look at our bulk shear on this to see how strong our bulk shear is, and it does look to be pretty favorable. You can see here this quarter by 0Z. Farther west here, I think the storms might be a little farther east than this, but this would be 60 knots, but maybe our storm development is more likely in this area, still over 40 knots, so I didn't mean to take that sounding there, but the overall does suggest storm organization to supercells would be very likely, and given all the other ingredients with our lapse rates, which will be very favorable, our K-bit all does suggest supercells will be the main initial mode. So looking at our storm relative velocity values, you can see how, except for across portions of eastern Kansas, they do decrease a lot during the day to a point that's not as favorable for tornadoes. But by 23, and especially by 0Z, these values do increase a good bit. That would then be supportive of that tornado threat, and our 0 to 3 levels are going to be even more favorable by 23Z. Values of perhaps around 250, which is basically the benchmark value I use for strong tornadoes. So that's mostly our look at the HR. That's a look at this model. Just to show the reflectivity output quick. You can see there's that line of storms up there. Here's our supercell down in central Oklahoma. And again, I do think we could see a little more coverage than this. Maybe some storms in this area as well. The environment's pretty similar, so it could just as easily pop up in southern Kansas the next run. But we are now going to take a look at our NAM 3K. First thing I'm going to show is our temperature, and just show how much lower the temperatures are going to be for this. You can see how we generally have just low to mid 70s for the most part. And as such, there's going to be a much stronger capping inversion in place on the NAM. And I don't think this is going to come through. Actually, we should have enough in it. Yeah, we have enough in our 18Z. So I'm going to be looking at this kind of with you together. I haven't taken a look at it yet. But we're just going to see what this does. It's the most recent model output. And we can see, it still keeps it pretty cool. So I would think that would still have a very strong capping inversion in place. I don't buy this solution as much, but I do think it is still important to realize it. And this does kind of slow a situation where the forecast were to underperform. If temperatures were to not warm as much during the day, you're going to see this very strong capping inversion would be in place, and that would suppress storm development. Again, maybe some elevated storms overnight capable of damaging winds and hail, but tornado risk would be basically non-existent with this NAM run. And again, I don't believe that. I think the NAM's underdoing the surface temperatures, but we can see this would basically be our only mode for severe weather. Maybe some elevated storms tend to favor a risk of hail, but then with that, if it's a linear storm mode, generally linear storm mode favors damaging winds, so it just be more difficult to get severe weather, especially widespread severe weather with that line of storms. But we are going to take a look at our lapse rates quickly, and all models are showing very good lapse rates. It doesn't really matter what one you look at in this case. But just for example, in the NAM, you can see you have these lapse rates of 8 to 9 kilometers generally across the warm sector. And that does show why with any supercell that does mature, why large hail is so likely with them. Again, very large hail, I would argue, is likely with any discrete supercell. We're just going to do a quick look at the Cape, and we're going to see how, well, first off, the dry line is further west. You can see that just right here. And we do have pretty strong Cape values, but no storms initiate on it. And that is, you know, that's certainly good news because we don't want severe weather, but I do doubt that somewhat. Hopefully that is the case, though. We are just going to show our moisture, because I want to compare the moisture from the to the HRRR here in a second. And you can see how, first off, the dry line's way farther west than any other model. This seems like an outlier in my opinion, but you can see our dry line's way further west, our mid to upper 60s dew points, even a tiny little area 70. I don't think that would actually happen, but still just shows our overall robust moisture access. And again, I think it's underdoing the temperatures, and as such, overdoing the capping inversion, and yeah, just no renegade cells. Not renegade cells, no cells forming along the dry line. Last but not least, we're going to take a look at our HRRR. The first thing I'm going to want you to notice here is how much weaker the moisture return is on the 18Z. You have generally low 60s, perhaps up to 64 in some spots, but how right along the dry line, dew points are in the 50s, so that will make it harder for storms to develop off that dry line. It's not going to be quite as sharp as a dry line, as sharp as a moisture contrast. Here, now we're going to compare our temperatures, and again, we're just going to see how basically every single model is warmer than the NAM, and yeah, well, generally upper 70s to 80s to mid 80s, and that just does show how that capping inversion again would be much more likely to break. Yeah, fine. Go to the capping inversion here. There we go. You can just see across central Oklahoma and Kansas how that cap just weakens a lot here. And I'll just take a sounding up here in south central Kansas. And again, the only reason this sounding is really marginal on the tornado risk is because the temperature dew point spread is 22. And that makes it extremely difficult to see a tornado, despite all other factors. And now, regardless on what the moisture return is tomorrow, assuming we get storms to develop, what we would see very large hail. We can see our lapse rates of over 8 kilometers, and that supports our very large hail. So, that's 2 to 3 inches. We could easily see that tomorrow with any discrete cells. We are going to take a look at our 850 jet on the HRRR. Also realize I never showed it on the NAM, so we should take a look at it on that too. And we can see by 23Z, so this is 6 o'clock, how our axis of around 40 knot low level jet is basically Oklahoma City and points north. And then if we increase across eastern Kansas, we do see that low level jet increase to over 50 knots. Which could support some damaging winds with that overnight squall line, or if there is still a discrete supercell ongoing, and that would greatly increase our chance of a strong tornado if we still have a discrete supercell ongoing. We're also just going to take a look at it on our NAM, because I realized I never showed it on that, and it seems to be looking a little different. It takes it a lot longer to fill in across portions of central Oklahoma. But it actually just looks a little bit weaker than maybe just a little bit weaker of an 850 jet on the NAM, but overall still going to be favorable for tornadoes and strong tornadoes across on this particular NAM run across eastern Nebraska and northern Oklahoma. It does take it a little longer to fill in across central Oklahoma, which would decrease the tornado threat if that were to happen. We are going to take a look at our storm relative helicity values quickly. And we're going to see how they do decrease a lot during the day. HRRR is the most conservative with our storm relative helicity values, especially during the day, but regardless, it does increase them going into the evening and overnight hours, which, again, that does show when our tornado risk would increase. So I believe that's going to be just about everything. Double checking, making sure I haven't forgotten anything. I don't think so. So that is, oh, I know what I forgot. Forgot to look at our day 2 risk. We're going to take a really quick look at that. Really just a quick look at it on our NAM 3K. Yeah, I have to edit this video within the next half an hour or so. I don't really have too much time, but we can see how as we get into the day on, actually no, I have to go back to our 12D to see far enough. As we get into the afternoon hours, we can see how this, here's our line of developing storms, and you can see here how it takes it further develop, really only develops in northern mode. I would think just based off the storm mode and that not as good lapse rates, that damaging winds would probably be our main risk. Especially further north, there is a stronger low-level shear, so I couldn't rule out a tornado, but I think damaging winds is probably the main threat for this slight risk. We'll take a look at our instability quickly on our NAM 3K, and we're going to see how it generally, further south, maybe 1,000 to 1,500 K, but areas further north, it's more spotty, but still sufficient, especially given that strong low-level shear. And we'll probably see that with our blend of cape and shear, our energy helicity index, how despite not a strong cape, it actually looks to be pretty similar values across the entire area. Kind of just shows how you need both cape and shear to get severe weather. But with that, that's going to be the end of the video. If you enjoyed it, please consider liking and subscribing. My link to my Twitter should be the conclusion, and I should be able to upload a video tomorrow before this event starts because I don't have school tomorrow. Don't know why, but I'm pretty happy about it, so that should allow me to upload a video earlier in the day. So hopefully we'll be able to do that, and I will see you next time. Bye.